On the set of axes provided, sketch the graph of f of x equals 2 log e of x minus 3 minus 2. Clearly label any axial intercepts with their coordinates and asymptotes with their equations. To start this question, we're going to consider the transformations that would have occurred to y equals log e of x to produce f of x. So the first thing that would have happened would be a dilation by a factor of 2 from the x-axis, and that's because of the 2 multiplying the log e function. Next, the graph would have been translated 3 units in the positive x direction due to the x minus 3 inside the log. And finally, it would have been translated 2 units in the negative f direction, or y direction, because of the negative 2 out to the end of the equation. Because the graph has been translated 3 units in the positive x direction, the vertical asymptote that was at x equals 0 is now at x equals 3 in this position here. And we label that asymptote with its equation. Next, we can move on to finding the x and y intercepts of the graph. So the y-intercept occurs when x is equal to 0 in our rule. So this will give us y is equal to 2 times log e of 0 minus 3 minus 2. However, log e of negative 3, so this part here, is undefined. And that's because we can't have a negative number inside the log function. It's undefined for those values. Therefore, there's no y-intercept, and that's because we have an asymptote here and our graph is going to go in the positive x direction. Next, we can find the x-intercept of the graph, and that occurs when y is equal to 0. So for our rule, we're going to have 0 is equal to 2 log e of x subtract 3 minus 2. Next, we're going to get the log e of x minus 3 by itself by adding 2 to both sides of the equation, then dividing by 2. Therefore, we're actually looking to solve the equation log e of x minus 3 is equal to 1. To solve this efficiently, we need to recall that log a of a is equal to 1. As the base of this log is e, we are in fact solving x minus 3 is equal to e will give this equation equal to 1. If we add 3 to both sides of this equation, we now find that x is equal to e plus 3, and that's the x-intercept of the graph. So now that we've got all this information, we can go about sketching our graph. So our graph is going to look something like this, where our x-intercept we found before at e plus 3, 0. Finally, because there's not a second axial intercept for this graph, it's good practice to put a second point on the graph. So we're going to consider the case if x is equal to 4. So that's just a value that's inside our domain for this graph. So this will give us y is equal to 2 log e of 4 subtract 3 minus 2. Therefore, we have y is equal to 2 log e of 1 subtract 2, and log e of 1, or log of any base of 1, is simply equal to 0. Therefore, we find that y is equal to negative 2. Therefore, on our graph, we'll have this point here, which is at 4, and f is negative 2. So that's the graph of y equals f of x.